Welcome to revision week 20. This is our second week looking at defensive design, and this time we're looking at testing and well-maintained code on maintainability. As always, make sure you've got your revision sheet 20 with you, ready to follow along and complete. Okay, just a reminder, we are talking about defensive design. What does that mean? It's making sure a program is designed so it functions correctly and does not crash. And things such as anticipating the things that could go wrong, the misuse of the program, preventing it from happening, making sure the code is well maintained, well looked after, and testing it to reduce the number of errors. The last week we looked at input validation, anticipating how it could be misused. This time we are looking at maintenance and testing. So, maintainability or well-maintained code, what is it? Well, when creating programs, it's important to make sure a program can be easily maintained, looked after, so that after you finish coding it, it can be updated easily and changes made easy to it. A program may decide to return to a program they wrote maybe months, years later in order to do something to it. Or another program may want to modify the program to improve it or debug errors. If a program is not well maintained, this is very difficult. So have a look at this. Why is this code not well maintained? What is bad about it? Well, firstly, it's all together. There's no clear structure to it. We've got selection statements here with if that should be indented to show the flow of the program. We've got variables that are not very clear, such as string, well, what is string? And the code is not explained at all. There's no explanation to person. There's no comments to explain it. So there is a much better version of the same code. We've got clear structures of the program with indents used. We've got subprograms that are used to make the code reusable. We've got clear variable names such as age, so we know what they're used for. And we've got comments to explain what the different parts or sections of the program are doing. Comments help to explain key features in the program to others. We've got subprograms that use to make the program clear and reusable. Indents that help to separate the different statements and show the flow of the program clearly, where it's going at different points. And suitable variable names or subprogram names that make it really clear and easy to understand what variables are being used for. So you can see here before and after. On the left, the badly maintained code, and on the right, the same code that's been split up into subprograms, again with comments, suitable variable names, so it's easy to understand for anyone looking at it. Why though? Why is it important to maintain code? Why bother? What are the benefits? It makes the code clearer to understand for others, users to read and understand. It makes it easier to edit or change parts of the code without risk of causing problems elsewhere because you know what the code is doing. And it's easier to spot and fix errors in the code. And it's also more efficient because there's less duplicated code, there's less code being copied and pasted and things. On your sheet, complete this section here, please. Code and maintainability. Checking your answers, as always, purple pen. Comments, explain features of the code. Indents, separate different statements, show the flow of the program. Clear variable names to understand what they're used for. Subprograms to make the program clear, reusable, and our benefits at the bottom here. As always, at least 2 benefits, make sure you know and remember. Okay, so we know what maintainability is. Testing. Why is it important to test again? Well, testing is essential to make sure there are no syntax errors, there are no logic errors, which are the 2 types we looked at last lesson, to make sure it does what it's supposed to. Does it meet the requirements? Is the performance okay, or is it very slow to run? Does it have good usability? Is it easy to use? And is it prevented from unauthorized access, things like authentication we looked at last time as well? So when you are testing a program, there are essentially two methods of carrying out testing. There is final testing when all of the requirements are checked at the end of the development cycle, and that is done once. Or there's iterative testing, which is repeated testing during the development cycle, to make sure the program is exactly like the customer wants. So key points. Final testing. The program only goes through the development cycle once. Goes through the cycle and all of the requirements are tested at the same time at the end. And it checks the main requirements have been met. But it might not be exactly what the client wants. The final program might not be exactly what the client wants because it's only tested at the end. Iterative testing though, the program goes through the development cycle more than once, several times. Features are added and tested a bit at a time, and the idea is to get exactly what the customer wants to meet their requirements. Testing is carried out several times, which can take more time, but you help to get exactly what the customer wants. Iterative, repeated. Okay, on your sheet, final versus iterative. Fill in the section now. Okay, as always, checking your answers. Final testing, program goes through development cycle once. All the features are tested at the same time once to make sure they work. Iterative, the program goes through the development cycle multiple times and features are created and tested a bit at a time. Okay, so we know the methods of testing. However, how is it carried out? Test plans and test data. Well, when you are testing is carried out using a test plan. This is an example of a test plan. A test plan is a detailed plan of how the program is going to be tested and what test data is going to be used. What values are going to be put in to do those tests. What test data. Detailed plan of how the program is going to be tested and what test data will be used. When you carry out tests, there are essentially 4 different types of tests that you use in a test plan. Normal test data, things that the user is likely to type in, a suitable value. We have boundary or extreme data, values at the very minimum and maximum limit of what the program should handle. For example, age, that might be 0 up to 100, the very minimum maximum. Invalid, the data is the correct type, but it's values that should be rejected by the program, such as -5 or 10,000 for age. And erroneous, think of erroneous as errors or error data, any inputs with the incorrect data type that should be rejected by the program, such as 35J, or maybe the word 35 typed in as letters instead of numbers. Erroneous. So think about this program here, central heating controls. It should accept the values between 18 and 30, so normal data would be 20, 25, 28, all acceptable. Boundary would be the very minimum maximum, which is 18 or 30, very minimum maximum. Invalid, -5, 32, outside of the boundaries. And erroneous would be a word, for example, the letter A, the word 20, or #20 hashtag, for example. Okay, have a look at the second scenario. In this scenario, we've got a sign-up box to enter their first name. A name should be a minimum between 2 and 10 characters long and only contain letters. Think, what type of test data would the following be? So, James. Well, that's a suitable value, so that's normal. Just letters. S on its own, well, that's less than 2 characters, so that would be invalid. JO, well, that is a minimum of 2 characters, so that would be boundary, at the boundary or extreme. Blank, well, that should be cause errors, so that's erroneous, because that should completely be rejected. Tiger lily, if you count how many letters you've got there, that is 10, so that's the very maximum boundary. Bob 1, well, there's a letter in there that shouldn't be, So that's erroneous, causes errors. Jason, that's normal, that's between 2 and 10. And Bartholomew, well, that's, if you count how many characters, that is more than 10, so that is invalid. It's a suitable type, but it's too many characters, so it's invalid. On your section, can you complete this part here? Test plans and test data now, please. Also, look at the example here of a road has a max speed of 70 miles per hour. What would be a suitable example for the different types here? Off you go. Okay, final section, checking your answers, please. What is a test plan? It's a detailed plan of how the program is going to be tested and what test data will be used. Normal values, suitable data, things that are likely to be input. For example, 55 for a speed of a car. Boundary, values at the very minimum and maximum. Or in this case, a maximum speed of 70, that is the highest value. Invalid, correct type of data, but that should be rejected. For example, -5 or 90, well beyond the boundaries. And erroneous, inputs with the incorrect data type that should be rejected. For example, ABC or 70 hashtag with an invalid character. Checking your answers now, please. Okay, as always, Learn Community revision quiz 20 this time. Check each answer, improve if not correct. Should be aimed for 100% as always. Good luck, and I will see you in lesson.